For two sets A and B, we have a relation R, which is the set of ordered pairs A comma B such that A belongs to A, B belongs to B, and A minus B is odd. Show that R is an empty relation from A into B. Okay, let's try to understand the problem. First, what we'll do, we are going to note down the two sets. Here we have the set A containing the elements 3 and 5. We have another set B. B also contains two elements, 7 and 11. Okay, now let's do one thing. Let's take the Cartesian product of the set A with the set B. So that means we have the set A with elements 3, 5. We're going to take its Cartesian product with the set B containing elements 7, 11. All we have to do is form ordered pairs. Now, how do we form the ordered pairs? We take the first element of the first set A, which is 3, form an ordered pair with each of the two elements of the second set. Here we will get 3, 7. That's going to be one ordered pair. The other ordered pair is going to be 3, 11. Next, we'll pick up the second element from the first set A, which is 5. 5 is going to be now used to form an ordered pair with each of the two elements of the set B. So we're going to get one ordered pair is 5, 7, and the other ordered pair that's going to be 5, 11. Okay, fine. Let's keep it aside for the timing. This is the Cartesian product of the set A with the set B. Now we are being provided with the relation R. Relation R is given as the set of ordered pairs A comma B such that A belongs to the set A and B belongs to the set B. Fine. And we have A minus B is odd. What does it mean? This simply means that we are going to form an ordered pair, the set of ordered pair A comma B, such that these ordered pairs are picked up from the Cartesian product of A and B. And here we have to pick up the ordered pair in such a manner such that when we take the difference between this, the elements A and B, it must give us an odd number. So let's say we start with 3, 7. We start with 3, 7 of the ordered pair. Now what does it give us? So here 3 minus 7, so that's going to be equals to -4. This is not an odd number, this is an even integer. Okay, fine. So we're not going to pick up this ordered pair. Next, if we pick up 3, 11, so 3, 11 simply means that we have 3 minus 11, so that's going to be 8. We have -8, so that's also an even integer. We're going to skip this value. Let's take 5, 7. So 5, 7 corresponds to 5 minus 7, that's equals to -2. Again, that's an even integer. And then finally we have 5, 11. So 5 minus 11, that's going to be equals to -6. So that means this is also an even integer. This simply tells us that any of the ordered pairs that we pick up from the Cartesian product of A and B, the difference between A and B is giving us an even integer. However, they are asking us to form a relation R. Now here, R must be a subset of A, the Cartesian product of A and B. That is how we define the relation R. But what we're getting here? We're getting here that none of them are odd numbers. None of them are odd integers. All of them are even integers. This simply means that R is actually an empty relation. There is no such element in the set R such that R is a subset of the Cartesian product of A and B. So that means R must be an empty relation from A into B.